Hi everybody. Welcome to the MATLAB 2014 MATLAB Virtual Conference. I'm Lurie, Vice President of Development for the MATLAB products. I'm going to be talking to you today about embracing technical computing trends with MATLAB. So let's dive right in. It helps to put a little bit of perspective into place. I like to describe about what are the elements of a great technical computing environment. And I draw this 2 by 2. I've got rows and columns. The rows are analysis and synthesis creation, and the columns are data and code. You can think of working with MATLAB as moving between these 4 different boxes, and I'm going to describe to you exactly how that happens. When you think about your workflow, you might say, well, an obvious thing that you do is data analysis. Maybe that's part of your job, or another part of that's obvious to do is programming, creating code. What's intriguing and interesting about MATLAB is not only can you do both of those, but you can also do these less obvious elements, the code analysis and the data creation, and often they're critical to get a great result from your system. So imagine if somebody shows up in your office and says, here's some data, please can you analyze it for me? So your task is a data analysis task. First thing you might want to do is write a little script that analyzes the data. So your data analysis task is performed by doing some code synthesis, writing a little script, writing a program. Now, you could just write the program, run it across the data, and say you're done. But that's not the case. To know that you've done it right, you really need to analyze your code, and that's the code analysis phase. And to do the code analysis correctly, you've got to ask yourself, is my code working correctly? To know if your code's working correctly, you want to create synthetic data. So create that data synthetically, run it through the code, see what the results are. You know what the inputs are because they're synthetic data. You check if you get your expected output results. And you're very, very quickly moving through the space. So even if you're doing data analysis, you're doing these 4 different tasks all tightly coupled together. One of the unique propositions of MATLAB is that you can seamlessly move between these four modes, these 4 cells, very, very quickly. And if you look at the code that you might write at the MATLAB command prompt, for example, you're stepping between those very, very quickly. So looking at the technical computing workflow a little bit here, it's very common to see accessing data, starting with accessing data, accessing your software, making measurements through hardware, and bringing them into MATLAB for exploration and discovery, doing some data analysis and modeling, some algorithm development, application development, and automating that task. And then when you're done, you want to share your results out, whether it's just reporting and documentation, outputs for design, or deploying your MATLAB code or MATLAB analytics into some other application. And MATLAB, these phases of data analysis, the algorithm development, and mathematical modeling can be used in many, many different fields, from image processing and computer vision, whether it's computational finance, signal processing, control systems, communication, even computational biology. For my talk today, I'm really going to highlight 3 trends that are impacting technical computing. The first trend is about new computing environments. The next trend is going to be about the rise of data analytics. And the third trend is the need for engineers and scientists to produce robust software. Let's take a look at the new computing environments. If you look around you, there are many, many computing options that you have. A real change from years past. In the past, computing was traditionally done on a desktop. You might have had a workstation with a large monitor. But now we've got many, many other computing options. We've got phones, we've got tablets, there's cloud solutions, there are GPUs for accelerating your computation, and there are very low-cost devices like Raspberry Pis to do computing on. And I'm going to talk about each of these and the impact of MATLAB and how MATLAB can help you use these diverse computing options. So multi-core and multiprocessors today, you can't buy a regular laptop PC or desktop that doesn't have multiple cores or multiple processors. The challenge here is you as a MATLAB user don't want to have to write special code in order to get the full power of these devices. And so since 2007, we've been taking all of our core functions and capabilities inside the product, the linear algebra, that's the heart of MATLAB, and threading those and allowing it to use the multiple cores on your behalf without you having to do additional work. Image processing toolbox has got multi-threaded functions, and you'll find many, many functions across the MATLAB universe that are going to really benefit from having multiple cores, and you don't have to make any code changes here. The next is CPUs and clusters and running code in parallel. So here we've got some code. It's a code snippet that we've got here where you've got a for loop and you're going to run some kind of algorithm 3,000 times. Now, traditionally, if you ran this code, it would run serially, which means if it does the, I equals 1, then it does I equals 2 and I equals 3, and it sequences through all of that. But if you wanted to run that in parallel, and if you had the parallel infrastructure available to you, either because you've got multiple cores on your machine and you've got the parallel computing toolbox, or you've got a cluster out there with a huge number of cores available to you, all you have to do to get this code to work correctly is to put 3 letters, PAR, in front of the for, and it will run in parallel. What will happen here is that different pieces of the algorithm will run on different cores and then be pulled back together, but the result will be exactly as if you had just run it serially. So you didn't have to do the work. You just needed to instruct MATLAB that this for loop you would like to run in parallel, and off it goes. There's a similar idea here on how to work with graphics processor units. If you buy a graphics processor unit or GPU from someone like NVIDIA, it takes a significant amount of energy to take your algorithms and code them if you're writing them in C or in some lower level language. If you're using MATLAB, however, we've made it really, really easy to take your MATLAB algorithms and your MATLAB data and take that data and push it to the GPU itself, do the computation on the GPU, and come back to MATLAB. And so this will accelerate many, many algorithms that can benefit from this kind of technique. So what we're seeing here is the CPU code on the left-hand side. And now introducing in blue is the additional code you would write to basically say, I would like some of these variables to actually be moved over to the GPU or computed on the GPU. And then all the computation, in this case, is a fast Fourier transform and a \solve. All of that is actually done on the GPU itself, and when the result is done, you can gather the results back into MATLAB. So very little code changes. You don't have to learn about the intricacies of setting up CUDA and all the issues behind getting a GPU to work. Just a little bit of MATLAB code to decorate your algorithm, and you can get great results here. The algorithms that benefit most from GPUs are when there's a core computational kernel that's run many, many times over a data set. There is going to take time to move the data from the CPU to the GPU, so you want a large amount of computation to happen on the GPU. Those are the kinds of algorithms that are going to benefit from a GPU. And there are lots of supported functions for these GPU arrays. Filtering, interpolation, eigenvalues, linear algebra, Fourier transforms, and a set of functions in the image processing neural network toolbox as well. Now, when I talk about cloud as a new platform, there's really been a big shift in the last couple of years. If you think of the first platform going back to the origins of computing, the first platform was the terminal. There were millions of users, thousands of applications. This was a mainframe and a mini. To an explosion was the introduction of the PC, the second platform, where hundreds of millions of users, the PC, the internet, large number of applications. And what we're seeing now is the emergence of a third platform. This third platform is the cloud, where you've got ability to access it from mobile devices, from browsers. There's a social component to it. You can compute big data. And so the cloud is a new opportunity for computing, a new opportunity to take your technical computing tasks and expand them and do them in a different way. So one of the ways you can expand and do it in a different way is to use MATLAB Mobile. This is an offering that allows you to have an interface to MATLAB on your phone or on your iPad. This could be Android-based or iOS-based. And it actually has 2 modes of working. The first mode of working is it can connect through the internet or connect through a wireless connection or wired connection to your desktop computer. So it's another way to control your local computer. Let's say you've run a long simulation. You go off to a meeting and you want to check, how's it going, and did it complete or not? Do I want to restart it with a set of parameters? You can take a look at it from your iPhone or mobile device. What's exciting is there's an alternative mode for MATLAB Mobile to work, which allows it to work directly with the cloud and allow you to do computation on the cloud itself. Your computer can be off. You can use it as a calculator. You can use it to run scripts. You can upload your own MATLAB files to the cloud and run them directly from your mobile device. Another way you can use the cloud is to take your desktop computer and to use the cloud for additional compute capacity. So let's say you've got MATLAB on your laptop and you want to run a large simulation with a huge number of cores. What you can do is you can start up the Cloud Center, and the Cloud Center will allow you to configure on Amazon a number of cores, as big a cluster as you want. Set that up on Amazon, get that going, and then your MATLAB will be able to connect to that cluster and do your computation. That par4, like you saw before, will just work directly with the Amazon cloud out there and get your results faster. So this is a way of taking the cloud and expanding your capability of your existing system. An alternative to you is to use the Amazon Marketplace. What Amazon Marketplace allows you to do is to take your MATLAB license and actually run your MATLAB on the Amazon cloud, and then you connect to it with a remote desktop-like interface so that you can interact with it. But this means that instead of having to have on-premise computing resources of any kind, you can do this completely in the cloud. Of course, you're paying Amazon for their compute time, but you get a lot of flexibility with respect to the hardware that you use for computation. Another application of MATLAB on the cloud is in the area of MOOCs. A MOOC is a massive open online course. Today, I invite you to go and listen to the talk of Andrew Ng from Coursera talking about using this new medium of online learning with these online courses to learn about, in his case, machine learning, and very, very successful way to get access to new kinds of learning for students, for professionals, and MATLAB is integrated into many of those solutions. So sometimes there'll be a question that'll say, you know, solve the following problem, and solve the problem by placing your MATLAB code in here. You can put your MATLAB code in, it'll be automatically graded, and you'll move through that course at your own pace, learning the really exciting and interesting concepts. And lastly, I want to touch on MATLAB Online. This is a pilot that we're doing for students, which is basically a browser-based version of MATLAB that allows you to log into MATLAB from a browser and get basic MATLAB experience. Here you can see there's a command window, the editor, and get the power of MATLAB without having to have any local install whatsoever. So this is a direction that we're moving here. Now, the students that might be using that MATLAB Online or other technologies are in the context of a new learning modality called project-based learning. And we're seeing this is very, very successful in education and in science. And so as part of project-based learning, it's really this hands-on, working with hardware kinds of applications can really accelerate the learning for students. And as part of that acceleration is this their availability of this amazing low-cost hardware, whether it's Arduinos or Raspberry Pis or Lego Mindstorm hardware. This hardware is low-cost, incredibly powerful, and flexible and programmable. And so students can get access to using these things and want to program them from within the MATLAB and Simulink environment. So let's see how they might do that. Kind of two ways to do that. The first is take the same board, let's say a Raspberry Pi, and you can write code inside of MATLAB that will communicate with the board. So this is the tethered approach. You kind of hook together MATLAB and the board itself, working together, sending messages, getting results back and forth over there. The other alternative approach is an embedded approach where you can write your code in MATLAB or Simulink, and then generate code that will run embedded on the device itself, and then you can disconnect MATLAB. So this can run autonomously, doesn't need to be connected to a high-end machine that's running MATLAB. And so these two modes are very, very powerful, either interactively working with the device itself from MATLAB by writing code, or expressing some algorithm that you want to have run on the device, drawing, in this case, the block diagram, saying what you want to say, and then pushing the button, downloading, and having that model or code run on the device itself. So very, very powerful tools. And I'd like to invite you to MakerZone. MakerZone.mathworks.com is a place where you can see fabulous examples of how to work with the Arduino devices, Raspberry Pis, Lego NXT. It's a whole community of examples and projects and ideas out there. And it's a great place to get inspiration, download some software, try some things out yourself, collaborate with other folks, and a very exciting, vibrant place. So take a look at MakerZone. The next trend I want to talk about is the rise of data analytics. And this is a really key trend here. We've heard about big data, lots of data that people want to analyze. There's huge amounts of compute power that's required to analyze this data. And there's this explosion of data. How are we going to process it and make sense of it? And that's the key thing. You want to make sense of it for either helping you do design or helping you make better decisions or better insights into your data. So there's a very nice model that I find is helpful to kind of describe the data analytics world. You start off with some kind of physical sensor that makes a measurement, that produces data. You're going to then take the data and transform it into information, organize it in some way, and then once you've got the information, you really want to try and understand that information to produce knowledge. And with the knowledge, you can take action. So starting at the beginning, you're going to have a process of observation. You're going to sense the data or collect the data from somewhere, do data acquisition, or pull it in from a database. And MathWorks has got a huge number of tools for kind of bringing your data into MATLAB, whether it's image acquisition or data acquisition or working with instruments or just pulling in data from a database or historian. But once you have it in MATLAB, you want to organize it. So that means you're going to want to filter it, do some data reduction, pre-processing, calibration, clean up the data, remove noise. And there are lots of tools and capabilities for doing this. A lot of them are in base MATLAB. There are more specialized tools in the signal processing toolbox or in the statistics toolbox to really help you in this organization task, moving your data to information. But where it really gets exciting is when you want to try and get an understanding of your data. This is the cutting edge right now. Techniques like machine learning, prediction and validation allow you to do clustering, regression, and other ways to make sense of your data, whether it's in the time domain because you've got time data or you want to transform it into the frequency domain. MATLAB provides you all the tools that you need for making sense of your data. But I'd strongly encourage you, if you've not looked at the statistics toolbox and neural networks toolbox as sources of ways to learn about machine learning, they're a great source and they've got a fantastic set of tools that can really help make sense of your data. But making sense of your data is not enough. You really want to do something with it. That might be integrating into an existing system, and I'll talk about that in a second, or providing feedback for design and operations or for the next phase of your design process, or taking that knowledge and packaging it up into a MATLAB application or a report that you might want to share with somebody else. So I talked about taking that knowledge and turning them into action. One way you can turn these into action is a new product we've introduced called the MATLAB Production Server. And this product is designed for you to take your MATLAB analytics and put it into production. If you've got a model, an algorithm that you want to service with large numbers of concurrent requests, build it into your environment. You can do that. It's designed to be scalable. It manages multiple production applications centrally. and is a very, very flexible tool for not only just using MATLAB, don't think of just MATLAB only for your R&D phase of the process, but really can be used for the production phase of your process. The software works very closely with the MATLAB compiler technology. So you take your MATLAB program or analytics, you run it through the MATLAB compiler, and you end up with a family of components that then you can reuse in production server and integrate into your databases, your web servers, or your application servers. Now, the third trend I want to talk about, and this is closely tied to the production use, is there's a real need to produce, for engineers and scientists, to produce more robust software. And there have been a couple of studies. This is one from the best practices for scientific computing, and recently published, talks about how scientists develop their own software and spend significant amount of time developing that software. But they're primarily self-taught and don't have exposure to some of the basic software development practices like code reviews and unit testing. So we've added and continue to add more and more capabilities to MATLAB to allow you to improve your software development skills, tools, and capabilities. The interesting part here is that at essence, there's always a trade-off when making software. And this is the same trade-off that traditional software engineers run into, but engineers and scientists do as well, which is given a fixed set of resources or a fixed set of costs, how do I trade off date, quality, and features? You can't have it all. You've got to pick at least one of those that is less important and subservient to the other. And so this is really important, that you have the tools to really allow you to do this trade-off and to explore this further. So some examples of tools are tools for improving code quality in MATLAB. MATLAB has a code analyzer. It's actually built into the MATLAB editor. If you're using the editor and you look on the right-hand side, you'll see a bar with some coloring in it. Hover over those. It's actually giving you advice on the fly on what you could be doing better and analyzing your code and making suggestions on how you can improve your code. Very, very powerful tool. And so it's developed here internally by the MathWorks with leading developers, and it's their insights that are available right to you in context with your code, giving you advice. Of course, we have a debugger for MATLAB that allows you to profile and debug the MATLAB code. But there's also some other exciting things here. There's a way to measure McCabe complexity or cyclomatic complexity. What this is there's a hypothesis that says more complex code is harder to maintain and is more likely to have defects in it than less complex code. McCabe complexity allows you to look at your code and assess which portions of your code are unnecessarily complex, and you might go in and re-look at them and see if there are ways to make it less complex and easier to maintain. MATLAB has the full power of object-oriented programming. For many folks, their introduction to object-oriented programming is through MATLAB, and MATLAB introduces the concept of classes with properties and methods, and you can have events and listeners. So it's a full-blown object-oriented programming system. This allows you to encapsulate your algorithms in a more effective way for certain kinds of applications. If you've not looked at MATLAB object-oriented programming, I strongly encourage you to do that. It allows you to put your code into packages which can scope or manage your namespace, so you don't have to have all of your MATLAB functions and classes in the base namespace. You can pull those out and manage them more carefully and simplify the code that you're writing. Another thing that MATLAB does is help you test your code. Writing that more robust software means that you're going to need to put in a test for the software you're writing. We've introduced the MATLAB unit test framework. There are actually two ways of working with it. If you're comfortable and familiar with object-oriented programming, go ahead and use the object-oriented interface. But there's also a function-based interface so that you can have functionally say, this piece of code, this is my expected result, this is what pass would be, this is what fail would be. and allow you to lock down the behavior of your code so that you can assure yourself it's working correctly when you or somebody else make changes in the future. You can also do code coverage reports, which is once you run the test, you can see what percentage of your code was actually covered by that test, and that will allow you to point to additional tests you might want to write so that your code is well covered. And then, of course, you can do report generation and publishing. Our publishing framework allows you to run the code and actually see the code results and have it published. And that's another way to look at if your code is doing exactly what you expect. And then you've got to share your work. The reports that are generated, of course, are available to others. But sometimes you want to take your MATLAB code and package it up, put a user interface on it, and make it an app. And so MATLAB now has the capability to package apps. You can deploy and share an app to a colleague who has MATLAB, or you can use the MATLAB compiler to turn it into an executable and send it to somebody who doesn't have MATLAB. And in addition to that, you can also generate standalone C code and HDL code from your MATLAB code. And that will allow you to take your MATLAB analytics, your MATLAB program, and embed it directly in some kind of embedded system or downstream system that you're integrating with. Now, as a software practitioner, as an engineer and scientist, you're not doing this alone. And in fact, there are many, many reasons to not reinvent the wheel. If you're trying to develop a new algorithm or do some kind of task in MATLAB, the first place you should go is to MATLAB Central. Go and search through the file exchange, and you'll find fabulous, fabulous examples of code, code submissions, toolboxes that have been written and are maintained by the community. There's a forum called MATLAB Answers where you can post your questions, and the community is in there supporting you and providing you answers. And so as you want to elevate your practices here, there's a great set of resources available to you. Codey is an environment I encourage you to go and take a look at, where you can challenge and expand your knowledge of MATLAB. There are these interesting coding problems. You can go and solve them yourself, and then you can see how other people have solved them and learn the tips and tricks on how to most effectively make use of your MATLAB. And then, of course, there are blogs where you can read commentary from MathWorks folks on how to work with MATLAB and the surrounding products, MATLAB, Simulink, and others. So this brings us to concluding the three trends: new computing environments, the rise of data analytics, and the need for engineers and scientists to produce robust software. I strongly encourage you to go and take a look at some of the other talks that are happening today. Andrew Ng is going to be doing the Coursera talk that I mentioned about MOOCs, and we're going to be also having talks on low-cost hardware. So enjoy the conference, and thank you very much.